Thank you. So yeah, hello everyone, and I'm really glad to be here today. So I will be talking about React Native and native modules because, as we just said, that's a great advantage of React Native to be able to dig into native code as soon as you need it. So let's get an overview of how the bridge between the JavaScript and the native works. I won't be too long because we already know it now. And then we'll see how to bootstrap a native module. And finally, what are the things that you must be aware on, the things that you should avoid or do when doing a native module. So a few words about me just before. I'm working as a software engineer at BAME. We are 40 people company based in Paris, and we're doing mobile applications. We started using React Native when the Android version was released, so it was quite well. Not everything was here at this moment. For example, we weren't able to access to the camera roll, the media library on Android, so we had to create a native module for it, and so that's how we began. And at one time, we had to create to send an image, for example, a profile picture from the app. For example, if you take a photo on your phone and send it to a server. And the problem was the image was really too big for it. So we decided to create a native module to reduce the size of the image. And that's how we created react-native-image-resizer, which is still working right now, contrary to the module that we have been making for the camera roll, because now there is an API for Android. So my talk will be, I will be making my talk using the experience that I have on this module. And as a side note, I'm also the author of gdevelop. It's a software that you can use to create games without programming, so it's really useful for artists or designer or anyone who wants to create games by learning how to code but without digging into real programming. So that's my side project. It's open source and you can Google it to find it. It's built with using C++ for now, but I'm moving it to React, and the new version is already available as a beta version. And finally, I'm also creating games in my spare time. So maybe you know Lil Bub, it's a cat. It's not a joke, and so it's a game where you can control the cat and go all around the world to find your spaceship, because cats come from space, of course. So yeah, let's get started. I've said bridge, and I think it's interesting to see what are the different kind of bridge in the existing framework other than React Native. For example, let's talk about Node.js. There is Node.gyp, I'm not sure about the pronunciation, that you can use to build native modules and to combine them with your JavaScript. If you look at Xamarin, they have bindings generators. Java, what about Java? It's already native? No, it's not really native if you compare it to C++, for example. So there are a way to do C++ in Java using Java native interface. Maybe you know about mscriptum. It's a way to have your C++ code compiled to JavaScript, and so there are bindings that can be created for it too. Cocos 2D.js is another engine that you can use to create games with JavaScript, but all the rendering is done natively. That makes make me think about another framework, and the bindings are made using large files of C++ that you can then call from JavaScript. And finally, React Native, there is the bridge. So React Native, the bridge in a nutshell. I won't be long again because we've already seen in the other presentation. So just a quick recap: when you create a new React Native app, what do you have? You have this: a few JavaScript files for Android and iOS. Of course, most of the time they are the same. And we have an Android and an iOS folders, and these folders contain the native app that will be hosting your application, meaning that they are creating the JavaScript engine, spinning up the JavaScript engine, and then starting your bundle. So the thing is that it's almost the same for a native module, meaning that you will have your JavaScript interface and an Android and iOS folder for the glue code and for the native code. A word about the bridge. Maybe you're now familiar with this kind of diagram. So the idea is that we have two threads, the main thread and the JavaScript thread containing the code that is being bundled. And if I'm not mistaken, I think it has changed, but native modules are running in their own thread. All you have to remember when doing a native module is that every message that you will be sending from the native to the JS code or from the JS code to native is that this message will be asynchronous. So most of the time it's not a problem because you're calling native functions for doing a specific work, but from time to time it can be painful. For example, if you want to avoid flickering, but apart from this, that will be okay for our need. A word about how message and arguments are sent over the bridge, because that is what you will need from writing native modules. If you send a message from native to JavaScript, arguments are sent using JSON. So that's the easiest part, and that was easy to implement for React Native authors. But when calling a native method from JavaScript, we have to do a bit more work. The idea is that we send the message using the module ID, the method ID, and the arguments, and everything is queued, so we can run it in a batch. The interesting part is that all useful types from JavaScript will be translated to native types seamlessly. So you won't have anything to do, and so your native method will be quite the same as the one from JavaScript. For example, number, strings, function, array, object, and even promise are supported. So out of the box, the support for arguments is quite nice, and you don't have to do a lot of glue code by yourself. So now that we know everything about it, let's go and see how to write a native module. So how to do this? Let's start by iOS. So it's quite simple. You open the documentation, read it, and that's done. Okay, that's a bit more complicated, but not so much. In fact, the documentation is really nice, so I will be explaining what is written in the documentation from now on. So you open Xcode, you add an Objective-C file. I won't be speaking about Swift for now. So you write your method. First, you open a book about Objective-C, then you write your methods, and you expose them with two simple macros, which are quite self-explaining, meaning that you can export a module and then a few methods inside this module. When you're done, that's almost everything. You can relaunch and recompile your app and use the native module by just importing native modules from React Native. So inside this object, you will find every native module that has been exposed using a React export method. So that's quite easy, and even if you're not familiar with Objective-C, you can get a hello world method running in I think half an hour. So even this code is coming from the documentation, so that's really easy. What about Android? Let's go and read the documentation. So same thing, open Android Studio, add a React context-based Java module. That's a bit verbose, but well, Java. And so the idea is the same. We have a class representing our native module, and we are exposing it to React during the startup in your React Java main application class. I don't remember the name. I think that's application.java. You add your package so that React is aware of its existence, and then you add the React package. So that was I was just talking about this. And finally, you can expose method using an annotation. Same thing as in iOS. The idea is that this method will be available at the end after your app is recompiled inside native modules. You can just import it from React Native and do a console log on it if you're not sure that it's here, but it will be working. And you can call your Java method without any other glue code. So that's really nice because it's just as easy to start a native module in your app. Everything that I've spoken about here can be done there directly in your app by opening the project inside the iOS or Android directory. That's a great strength of React Native, to be able to dig into native code by just in like 20 minutes. You don't have to create a real separate module to use native code. But speaking of native module, let's see how to do a real one. For example, if you are satisfied with what you've done, it can be a good idea to make it open source, and that's what we did, for example, with react-native-image-resizer. So let's do this. Let's create a module. First thing is to bootstrap an empty native module. The next slide will be about it because they are solutions rather than copying an existing one. And then set up a blank React Native app. The idea is you're not forced to do this, but my advice would be to always have a React Native app ready to that you can commit inside the code of your native module, so that you can test your native module. It acts as a test bed, in fact. So it has two advantages. The first one is that you are able to quickly test your native module without running a full application. And the second advantage is that anyone who is trying your native module can just launch this app and see that everything is working as expected or not. Just a prototype that I got from a contributor. In your package.json, the one from the test application, you can use a file dot to require the native module that is in the parent directory. So that's really useful because you're sure that when someone is launching the test application, it's really using the latest version of your native module. And when it's done, you can just npm publish. Let's see. The most difficult part, in fact, is bootstrapping an empty native module. So there are a few solutions, and there will be a lightning talk about it, about the second solution, React Native Create Library. And I've also listed two other solutions. We have our own generator that we made a few months ago. I think it's not up to date, so just stick to the two others. And the last one, React Native Create Bridge, is quite nice because it supports Kotlin and Swift. And I've been told that Kotlin is quite nice, so that's maybe a good idea to give it a try. Okay, we have a module that is bootstrapping. What I will be doing now is to explain what you can use to make everything easier when you're developing using native tooling. Because tooling is important, everyone knows it, but it's even more important when you are working with native module and you're not familiar with everything that is existing in the native realm. So the first tool that you can use is the console output. Sounds obvious, but using this, you can at least make sure that your native module is running properly, and that's a good start. And it can be really useful if your native module is doing some kind of initialization based on configuration. So it's an easy way to tell, for example, to the user, to the developer, sorry, that he is misusing your module. For example, here is a message from the one senior react-native SDK telling that the app ID wasn't filled properly. So these are this kind of thing that avoid developers searching for half an hour for a solution because of a silly mistake. So yeah, console output. Another thing to do is to use native debuggers. I think that everyone here loves Chrome debugger. It's so nice, but we do have also powerful native debuggers. Here is the one from Xcode. So my advice will be to get familiar with native debuggers. So it's just as easy to use as any JavaScript debugger. You can add breakpoint in your code, inspect variables, add watch expressions, and you can even try to print the value of variables and to try to call methods, for example, to check the return value of something. So yeah, there is. I don't have a screenshot for Android Studio, but same thing here. Just add a breakpoint, start your application with the debug, the run debug menu, and you will be able to see everything that is going on. Another thing that you can use is view inspectors. These are the bombs. If you're doing an UI component, I think that's the best way to see if everything is all right. So the idea is that view inspectors are showing you the native components that are shown on the screen, but in a fancy way here. So to run it on Xcode, it's the button that I've highlighted here in red. This is amazing because the first time you start an application and you use this feature, you can see that you are really doing a native application. So that was not a joke, that was not a web view, that's real native. That can be useful if you're trying to develop a native UI component and nothing is showing. You have the same for Android. You can launch it using Tools Android Layout Inspector. There is no 3D view as in iOS, or at least I'm not aware of it. But same thing, you can see the native component, and that can be useful to see if, for example, your native UI component is displayed or not at all. Next thing is the bridge profiler. So we've been speaking about the bridge earlier, and there can sometimes be some problem of data. For example, if the data you are sending on the bridge is too big or there is too much data, well, the bridge can get slow because there are too much things to process. So there is quite a nice module called RN Snoopy that is able to display, in fact, everything that is going on the bridge. So here, when the app is crawling, we can see every command that is sent to the bridge. And you can do it by yourself by using message queue.spy. If you call it with true as an argument, you will see every message that is sent over the bridge. So anytime you're working with native components, that's the way to go to see if you're not overloading the whole bridge. And it can help you to find a bottleneck in your app. Okay, next tool, and I think that's the last one. The memory profiler, the native memory profiler can be useful. For iOS, you can launch instruments, and then there are a bunch of tools that you can try them all. That's quite funny. And for example, for Android, you can launch the Android monitor and see how the memory is going. When creating react-native-image-resizer, we had first a few params of memory because image can be too big. So we must handle the case where the memory is blowing up by catching an exception. And so these tools can make you confident about the way you are using the memory, because it's quite easy to leak resources if you don't take care, especially in Objective-C. Okay, let's finish by a few words about things that hurt. You weren't expecting this transition, right? First thing is handling exception. As I said, for example, it's quite easy to forget to handle exception, in particular in Java, even if the Android Studio is telling you to do so. And for example, here is a pull request that I've received a few days ago on react-native-image-resizer. So thanks to this guy, hopefully we will have a proper handling, exception handling once it will be merged. So that was my face when I saw this pull request. But yeah, anyway, just make sure to properly handle exception and you will be good. And I think that's maybe easier on iOS because you have to check the return code of everything that you're calling in Objective-C. So yeah, just take care. I was speaking of too much data over the bridge. That's a kind of congestion, like a real bridge. So the idea is that if you are sending too much message, you can end up overloading the bridge, and the whole app will feel slow. Even if the UI thread is running on his own, you can have some kind of flickering, as we were told earlier. So Aaron Snoopy can be a good way to check if that's the case or not. I think that for most native modules that won't be the case because you're just calling a few methods from time to time. But I don't know if maybe if one day you're trying to create something that is highly interactive but sending message to the native part, for example, to animate something on the screen, beware of this issue. Too much data, but data can be too big sometimes. For example, on react-native-image-resizer, we don't send images content over the bridge because they are images and they weight a few megabytes. So don't send files over the bridge. Sounds obvious, but better tell it so that nobody won't make the error. And finally, yeah, just keep working with file paths. If you have large chunks of data, for example, the result of an image that has been processed, or if you have, for example, the result of a calculation, or I don't know, something that is large, better save it to a file and then send it using native file upload, or keep it in cache and display it later, but don't send it over the bridge. Okay, and one last thing to keep in mind when creating native modules is to be aware of breaking changes. There are two kinds of breaking changes. The one in your native module. So my advice would be to follow semantic versioning. That is basically to upgrade the major version of your library whenever there is a breaking change. So that's quite simple, but you can use tools like committizen. So anytime you're doing a commit, you are asked for a commit name that is following a specific format, so that it's easier to keep track of breaking change and then to know if you must upgrade a minor or a major version number. And so that's the easiest part. The harder part is to keep up to date with React Native. So from time to time, there are changes in the native interfaces of React Native. So you may be forced to support only the latest version of React Native after a change. For example, there was a time when the iOS header paths have been changed. So we had to release a new version that wasn't backward compatible. So you end up with not this, but with a README telling you to only install a specific version for a specific version of React Native. But well, that's okay because the breaking changes are not happening so often, and plus I've added emojis, so that's all good. I think that's pretty much it. So if you want to follow me on Twitter, here is my Twitter handle. I'm also on GitHub. You can see my open source game development software if you're interested. And if you have any friend or yourself, if you want to create a nice application in Paris, just give us a call. So yeah, that's it. Thank you.